Have you ever wondered how combustion takes place in a piston engine and in a gas turbine engine? In our last video, we looked at the fundamentals of an aircraft engine. We looked at how thrust is generated and what's needed in order for thrust to be generated. If you haven't watched that video, there's a link to the video in the description below. In this video today, we're going to be looking at the difference in how combustion takes place in a piston engine and how combustion takes place in a gas turbine engine. So welcome and enjoy the video. A piston engine is an internal combustion engine. Some piston engine operates on a two-cycle principle and some operate on a four-stroke principle. In this video, we are going to be looking at those piston engines that operate on a four-stroke cycle. Combustion in a piston engine takes place inside a cylinder. The piston travels from the top dead center to the bottom dead center, or from the bottom dead center to the top dead center to complete a stroke. For the four-stroke cycle, 5 events take place, and these are what we're going to be looking at in this video. The first stroke begins by the inlet valve opening in the cylinder head and the exhaust valve remaining closed. The piston travels from the top dead center going downwards inside the cylinder up to the bottom dead center. As the piston moves down, fuel-air mixture is allowed to flow inside the cylinder through the intake valve. And this is what is called an intake stroke, and the event that takes place in this stroke is the intake. The second stroke begins by the piston traveling from the bottom dead center going up to the top dead center. As the piston goes to the top dead center, both the inlet valve and the exhaust valve are closed. Due to this movement of the piston from the bottom dead center to the top, the pressure inside the cylinder increases. And as the piston nears the top dead center, a spark occurs to ignite the fuel mixture in the cylinder. And this causes a rapid increase in pressure inside the cylinder. As a result, the piston is pushed downward from the top dead center to the bottom dead center by this increased pressure inside the cylinder. This force is what is transmitted with the connecting rod to the crankshaft. This force is what is converted. Remember, this push is a linear motion, or is a linear force. And this force is the one that is converted by the crankshaft into a rotary motion or into a rotary force. And this force is the one that is used in driving the gearbox and the propeller to generate the thrust that propels the aircraft forward. This stroke is called the power stroke. This is the third stroke that occurs in the four-stroke piston engine. The last stroke is the exhaust stroke, and it starts by the piston traveling from the bottom dead center going upwards to the top dead center. During this stroke, the exhaust valve is opened to allow the exhaust or the scavenging of the burnt gases in the cylinder outwards. So the 5 events that takes place during the four strokes are as follows. There is intake, that takes place during the intake stroke. Second, there is compression that takes place during compression stroke. And there is also a third event, the ignition, and this also takes place during the compression stroke. The fourth event is the expansion, and this expansion takes place during the power stroke. And finally, there is the exhaust event that takes place during the exhaust stroke. So these are the 4 strokes and the 5 events that takes place to complete one cycle of operation of a 4-stroke piston engine. After this, the event repeats again and again and again. In a piston engine, there are a number of cylinders. You can have a piston engine with 4 cylinders and another piston engine with 8 cylinders or even 12 cylinders. And during the operation of an engine, different pistons are at different stages or different strokes in their respective cylinder. This is to ensure that at any given time, there is a piston producing power to rotate the crankshaft and thus to rotate the engine and thus produce the power that is needed to propel the aircraft forward. We look at this graph here to explain these events further. This is a pressure volume graph, and this is the beginning of the first stroke, which is also the end of the final stroke, because as you know, this is a cycle. When it reaches the end, the first stroke again starts. This is the top dead center, and this marks the bottom dead center. As the piston goes from the top dead center to the bottom dead center in the intake stroke, the volume inside the cylinder increases, and as the piston reaches the bottom dead center that marks the end of the intake stroke, the compression stroke starts by the piston traveling back towards the top dead center, raising the pressure inside due to the compression inside the cylinder. As the piston nears the top, ignition occurs, and this one causes a further increase in pressure up to the top dead center. From this point, the piston is pushed downwards in the power stroke. This event is known as expansion, and this force is the one that we've said is used in order to rotate the crankshaft, which in turn rotates the propeller or the gearbox. At the end of the power stroke, the exhaust valve opens and exhaust stroke begins by the piston traveling from the bottom dead center to the top dead center back where it started. This cycle is known as a constant volume cycle, because during the whole time of operation, the volume that was allowed to flow inside the cylinder remains the same from the first stroke up to the last stroke. And this is why it is called a constant volume cycle. Next, we look at the operation of a gas turbine engine. A gas turbine engine is also an internal combustion engine. Combustion takes place in the combustion chamber, unlike in a piston engine where combustion takes place in a cylinder. The events that leads to combustion in a gas turbine engine all take place at the same time, but in different components. The major components or the major parts of a gas turbine engine are the intake, the compressor, the combustion chamber, the turbine, and the exhaust. Air is allowed to flow inside the engine through the intake, and from the intake the air goes to the compressor. At this stage, the air is compressed, increasing the pressure of the air before it is allowed to enter the combustion chamber. In the combustion chamber, heat and fuel is added to the air inside the combustor, and this is where combustion takes place. During this time, the temperature of this mixture is increased and the volume as well. From the combustion chamber, this burnt gases passes through the turbine, where the main function of the engine takes place. This is where the energy to drive the compressor is extracted, and also the energy to drive the accessories of the engine is extracted. From this point, the burnt gases from the turbine move to the exhaust, where it is expelled rearward at a very high velocity. And remember from our previous video, this is what is known, or this is the action that in turn produces the reaction that propels the aircraft forward. I will also use a graph to illustrate these events. The process starts from here. Once the air is delivered to the compressor, the air is compressed where the pressure is increased up to this point. From this point B, the air goes into the combustion chamber where heat and fuel is added. This increases the volume and the temperature inside the combustion chamber. From this point, the burnt gases goes through expansion, and this is done, or this occurs through the turbine where the energy is extracted to drive the compressor and accessories. If you remember, the volume of the gas increases, but the pressure of the gas decreases to almost ambient just after the exhaust. This cycle is called the BRYTON cycle. It is sometimes referred to as a constant pressure cycle. The reason for this is because The pressure of the air just before the intake and pressure of the air after the exhaust is more or less the same. This is the reason why this cycle is called a constant pressure cycle. Thank you for watching the video till the end. If you haven't subscribed to the channel, I humbly request you to click the subscription button below and turn notification on so that you'll be notified each and every time we post a new video. Thank you, and I'll see you in the next one.